Hello everyone and welcome back to Newton's Academy past paper review for grade 12. Today we will be doing a mathematics past paper question on Euclidean geometry. We will be focusing on question 7 that we see on the screen. So question 7 gives us a diagram with a circle and some lines, some triangles drawn in the circle, and it tells us O is the center of the circle, PWSR is a cyclic quad, PSWO and OS are lines that are drawn. They tell us PW and OS are parallel, so we should be on the lookout for fun angles, and they give us one angle to start with, and that is angle P1, which is equal to 36 degrees. So the first angle, or the first question that is asks us to find the size of angle SOW, which is this angle here. Okay, so they want us to find SOW. So looking at SOW, O is the center of the circle. And looking at a circle center O, we see that the points S and W subtend this angle SOW, and the same points S and W subtend this angle P1. So we can see that this forms theorem 2, which is angle at the center is twice the angle at the circumference, because the same 2 points subtend this angle at the circumference and the same 2 points subtend this angle at the center. Therefore, SOW will be 72 degrees. Why? Because angles at center equals twice the angle at the circumference. Okay. Looking at question 7.2, it asks us to calculate W2. Now W2 we can see lies on a parallel line, and so does SOW, which we have just calculated. Therefore W2 and SOW will be equal due to alternate angles. So W2 is therefore equal to 72 degrees as well, and that will be alternate angles. And when stating alternate angles, we have to mention the parallel lines, so that will be PW is parallel to OS. Okay, question 7.3 asks us to calculate angle OSW, so that angle there. And we see that angle OSW lies in this triangle SOW, lies in this triangle, and this triangle comprises of two radii, because O is the center of the circle. So those two lines are equal, which means W1 and OSW are equal, and we already know that this angle is 72. Therefore, we can calculate the value of the two unknown angles. Why? Because we know that both those angles are equal. So we start off by stating OW. So for 7.3, OW equals OS, and the reason being equal radii, and therefore W1, angle W1 equals angle OSW, and that is angles opposite equal sides. Okay, now that we know that those two are equal, we can go ahead and use our sum of angles in the triangle formula to solve for the unknown angles. Why? Because now we know that those two angles are equal, therefore twice W1, which is basically W1 plus OSW, plus the last remaining angle, which is 72 degrees, is equal to 180 degrees. The reason there is sum of angles in a triangle. Okay, so solving for W1, making it the subject of the formula, we will get W1 to be 54 degrees, and therefore OSW will also be equal to 54 degrees. Okay, moving on to question 7.4, it asks us to calculate the value of angle R, which is that angle there. And we know that R lies within the cyclic quadrilateral PWSR, and there's two theorems involving cyclic quads that we need to know. Theorem 5, Theorem 6. That is opposite angles of a cyclic quad and the exterior angle. And obviously we know that there is no exterior angle in the cyclic quad. We are not given an exterior angle, so we should be on the lookout for theorem 5. And we see that we should be able to use theorem 5 to solve for angle R. Why? Because theorem 5 states that the opposite angles of a cyclic quad are supplementary, meaning they add up to 180. So R plus W2 and W1 should be 180, and we've already solved for W1 right there, and we've solved for W2 there, so we can simply go ahead and use that reasoning and expression. So we said angle R plus W1 plus W2 will equal to 180, and our reason is opposite angles of a cyclic quad. Okay, and then we go ahead and we substitute. So we know that W1 is 54 degrees, we know that W2 is 72 degrees, and that will equal to 180. So when making R the subject of the formula, we will get R to equal 54 degrees. And we have now solved for all the angles that the question has asked us. So that brings us to the end of this short question on Euclidean geometry. Thank you for watching.